Hi class, welcome to another lecture on CS575. This time we will look at an interesting concept known as covariance. Right? So till now we were seeing only a single set of observations, right? Set of x values or set of y values. Now when we include the term co basically means joint. Okay? So whenever we include the term co is either joint or common. So now in this case, when you see covariance, you want to have a relation between more than one values, set of values. For example, a simple example would be, let's say I have x and y values. So let us say x is 1, 2, 3, 4 and this is 10, 15, 16 and 20. Right? So I want to check here that what happens when I increase x, like when I am going from x from 1, 2, 3 and 4, what is the corresponding variation in y? Right? So this is what we do in covariance. Covariance, as I said, joint. So jointly how much are they varying together? Right? So we know the formula for variance is like, for when we take only a single data set, we have x minus x bar whole square divided by n and summing up to the n values. Now since this is only a single value, we take it to the square because we want to neglect the negative terms. But in case of covariance, so I will say s square, right? So let me keep it covariance. So I will make it c of x and y is very similar to this formula. Since we are doing it a joint thing, we call it this one. So if you compare with this formula, it is exactly the same, right? If I expand x minus x bar twice and just replace that x minus x bar with y minus y bar, I get the formula for covariance, right? So usually what happens, right? I can represent a graph here, right? So let us take this is the height and this is the weight. Right? So what usually happens, like when at the birth of a child, right, the weight is also less, the height is also less. As the child grows, the height will also increase, the weight will also increase, right? So you can see that you will observe some kind of this distribution. So I can see some kind of symmetricity here. Symmetricity means, for example, if I draw a line here like this, so I can see that this is a trend for which this graph is going. So for example, we say that, okay, if I take this particular weight, right, so from this point to this point, so I can say that for a given weight x, right, so let us say this is a weight x, the height of the individual will be between these units, right? So I just draw a straight line and I take the markings on the y-axis. So now you can see a general observation that you observe is that as the weight is increasing, so for example, if I take another weight, let's say p, right? So now you can see that if the weight of the person is p, right, so this is the height estimate, right? So in this particular case, you can see there is an increase in the variation, right? As the weight grows, the height also grows. So we call this as kind of a positive relation between the variables. So weight and height are positively related to each other. Now let us see an example of a negative covariance. So let me take another graph. Right. So in this particular case, let us say these are exercise minutes. Right. So the number of minutes that you do exercise, and this is the heart rate. So what happens? Let me just check for the example. Okay, just a second, class.